All right, ladies and gentlemen, today we're going to be talking about angles within triangles yet again, but we're going to be focusing on a certain specialty. And if we take a look at my screen right here, we can take a look at triangle ABC. And I named triangle ABC because those are the 3 points of this triangle. And I'm telling you over here in this little description that ABC is a right triangle, and I can even see that angle B is my right angle over here. What I've done is I've drawn that same triangle over here, and what we'll do is we'll take a look at these notes underneath here and walk through them. So in triangle ABC, we know that angle B is the right angle. And some things that we already know about triangles. I'm going to move over here. And all 3 angles in a triangle add up to a certain number of degrees. And that's 180 degrees. So all 3 angles, we can say that the measure of angle A plus the measure of angle B plus the measure of angle C all add up to 180 degrees. It doesn't matter if angle A, angle B, angle C have the same measurements or different measurements. Obviously, this is a right triangle, so they're going to have to be different. But we don't have to know what those 3 angles are right now. All we have to know for sure is that whatever A is plus whatever B is plus whatever C is, they have to add up to equal 180 degrees. Now, for the next part of this discussion, we need to think about the right angle part here, angle B. So a right angle has a certain number of degrees in it. So that number we know is 90 degrees. So all right angles have 90 degrees in them. That information is going to be extremely important. So when I think about this angle over here having 90 degrees, okay, great. This angle has 90 degrees over here. So can I figure out what these 2 angles have? Well, perhaps not individually. I might not be able to tell you that angle A is a certain measure or angle C is a certain measure, but I can tell you that the measure of A plus the measure of C add up to a certain number of degrees. And that's a magic number that you and I are going to be working with today. So if I have 180 degrees in a triangle, and I have 90 degrees in my right angle, okay? And let's play this game right here. There's 90 degrees in this angle right here. We've already solved for it. Now we have to solve for this angle plus this angle. We're going to be left with 90 degrees. So these 2 angles, okay? So whatever A is plus whatever C is equals 90 degrees. So let's ask a few questions here. What if we said that A was 80 degrees and C was 10 degrees? Would this continue to be a right triangle? And the answer is yes, because 80 plus 10 equals 90. What if I said A was 20 degrees and C was 80 degrees? Is this continuing to be a right triangle? Well, the answer here is no. Because if I have a right triangle, I have 90 degrees plus 100 degrees means that this is now 190 degrees, not a triangle any longer. To explore this, let's take a look at the document camera over here to my left, and we'll get some light on this board over here, and we'll switch the slide. So as we take a look at triangle ABC, once again, we're going to be thinking about not the right angle, angle B here. We're going to be thinking about these 2 angles. And remember, it doesn't matter, okay, what these angles are individually. The question that we're asking you right here on this line, the measure of angle A and the measure of angle C, is not asking you for what is A or what is C. We don't have enough information to do that, so you can't take a guess. What you can say, though, is you can tell me that A and C together have to be the amount of degrees that are remaining. And again, that's 180 degrees in a right triangle minus 90 degrees in a right angle equals 90 degrees. Now, when can we get a little bit more specific in finding one of those two acute angles? Well, down here in this triangle, we have triangle DEF, okay? And we'll name it, we'll call it triangle DEF. So in triangle DEF, we have a right triangle, and that's at angle E. And angle D, we're telling you, is 17 degrees. So could I sit here and add up what is 90 plus 17? Sure, and I'll get 107, and then when I subtract 180 minus 107 degrees, I'll get 63 degrees. Correction, I'll get 73 degrees. So I get 73 degrees right here, and if I get 73 degrees in this corner, perfect, I'm done. However, right triangles allow me to work a little bit faster. So instead of worrying about this work here, where clearly I made a mistake, let's try to get 60 or 73 degrees a different way. So remember, this angle is worth 73 degrees. And when I go to do this work, I keep in mind that I don't have to play around with these 90 degrees. So I know that if I do 90, which is the remaining number of degrees between B and F, or D and F, and I subtract the 17 degrees that are in angle D, when I borrow and subtract, I will have 73 degrees left, and this is the measure of angle F. Okay, so what we did here was we did some subtraction, but we worked with the fact that angle E is a 90-degree angle. And if I can use that principle, then I know that when I take 17 degrees away from the remaining 90, I'm going to be able to find angle F. What has this done for me? It's eliminated one of my steps of math, and it's eliminated some borrowing and carrying out of 180 that might give you some room for error, like it gave me room for error a couple of times while I was giving you this example. So it is extremely important to check your work, which is what I did and how I caught my mistake in that problem. What we're going to do right now is take a look at this next example. And on this example board, we have a crazy triangle system. I'm going to try to keep the glare here off to the side of the problem where it's not going to interfere too much. So here I have two triangles. And the wonderful thing here is that they are both right triangles. So here I have triangle WXY. So when I say triangle WXY, it's not like angle WXY where we say, oh, we start at W, we go to X, and we end at Y. In triangle WXY, we start at W, we go to X, we go to Y, and then we swing back over to W to complete the triangle. Okay, I also have triangle XYZ. So I'm going to start at X, go over to Y, go over to Z, back to X. Both of these are right triangles. Okay, and for that reason, I told you WXY is a right triangle right here, and triangle XYZ, the right angle is right here. Okay, ideally this name should have been XZY, but that's okay. For right now, we're going to tell you that the measure of angle ZWX is 25 degrees. So here's angle ZWX. So that means this part right here is 25 degrees. And what comes next on this board, we need to find the measure of angle WXZ. Well, now we need to do some thinking. We have down here, where we pass point Z, we're playing with the rule of 180. This is angles on a line. How many right angles make up a line? Well, that's two right angles. If there's a right angle on this side, there has to be a right angle on this side. And the reason for that is because 90 plus 90 equals 180. So I know that this is a right angle right here. Now, if this is a right triangle in here as well. We didn't learn that XZW was a right triangle, but it is a right triangle. What we can do then is use that rule for right triangles, subtract from 90 to figure out what this missing angle is up here. So what I'm going to do now is I'm going to figure out WXZ. And to figure that out, I'm going to do 90 minus 25. And I'm going to get 65 degrees for this angle. So the measure is 65 degrees. Now the next angle that I'm asked to find is ZXY. So I'm going to bring us back up here. And ZXY, I'm finding this part of the missing right angle right here. And what I'm going to do is I'm going to have to do 90 degrees because this whole angle is 90. And I know that part of it is 65 conveniently. So I'm going to subtract and find that this is 25 degrees. If it wasn't 25 degrees, this wouldn't be a right angle up here and something would be wrong with our problem. So this is 25 degrees. So I'll record that down here on the line. And then the final angle that I'm asked to find is the only missing angle now, and that's angle XYZ. So I have angle X, angle Y, angle Z. And again, I would have to do 90 minus 25. I've already done that math. So this is a 65-degree angle in here as well. So I write my 65 degrees, and I'm done. Now, you can notice that today we're saving you a couple extra minutes in terms of all the math that you have to do because you don't have to add up the two angles and then subtract from 180. We know that the two acute angles in a right triangle always add up to 90 degrees. And that's a rule that can be very, very helpful in saving you some time. Here we have another crazy right triangle system, and we have triangle MNO, and we have triangle NPO, and we have this is a right triangle here. We have this is a right triangle. This is a right triangle. We have lots of right triangles that we're going to be dealing with. So let's see if we can figure out this missing angle right here. We'll call it angle PNO. So let's try to figure out what this missing angle is here. What information am I going to have to use to solve for that? Well, if I look at triangle PNO right here, I see that I have the right angle, very helpful. And I have this 37-degree angle over here, also very helpful. So once I have that 90-degree angle, I know that I don't have to play with 180 anymore. I can play with 90, and this is a one-step problem. So now in order to figure out what this is, I'm going to start with the 90 degrees that I have left between my angle over here by N and by O. And I know that O is 37 degrees, so that's the part of the 90 that I already know. And when I subtract, I'm left with 53 degrees up here. Fantastic. And if I wanted to know the other side, let's just do this one for fun right now. If I wanted to know what this angle is right here, I would have to do 90 minus 53, because 53 is part of this 90-degree angle right here. And when I subtract, I get 37. Now, what if I was a mean person and I had drawn this arrow up here? Well, then yes, I would have had to solve this angle first to get this 37-degree angle, realize that this right angle box is also on this side of the line, and then solve for this angle up here, which would have been 53 degrees. Today, what you're going to be doing is you're going to be looking at problems that we're selecting from the workbook. And as you're working in your workbook today, you're going to be taking a look at questions that ask you to think about what the angles are, okay? So for example, in one of these problems, the measure of angle B here has that wonderful little hint box there, all right? And then the measure of angle A and the measure of angle C, well, if we did the math for this, it would be 180 degrees in a whole triangle minus the 90 we know for angle B. And that's going to be how much is left for A and C when they're put together. And that is 90 degrees. Okay? So the same thing is what we can think about down here for angles G and F. What are angles G and F going to be when we add them together? Because we can't solve for them separately right now. When we look at these problems down here, you want to be careful and think about, are these possibly right triangles? So for example, if I add 70 and 19 together, I'm going to get a number. When I subtract that number from 180, since I don't see a right angle box just yet, if that number isn't 90, this triangle will or will not be a right angle. Okay, so you need to think about that. If I see a right angle box, which I only see on this one right here, then that triangle should be pretty easy to identify whether or not it's a right angle or not. You might have to add up the angles and subtract from 180 to see if there's any way that there's a right angle there. Also, check out those angle measures very carefully. We'll be giving you these couple of problems to be working on. Make sure you read on the Google form which angle we're looking for you to solve for in a specific blank. If you have any questions, as always, make sure you're reaching out and enjoy working on your angles within these wonderful right triangles today.